Now I continue my example from before with two different price curves, which is a price function, and that's the reason why we made this a horizontal addition of the marginal revenue. I've done that in the previous video. We found the marginal revenue was 160 minus 1 over 200x for the added curve. The new information is that the variable cost is 20x plus 1 over 1000x squared. So that's a function for the total variable cost. So to be able to find the optimal price where marginal revenue and marginal cost intersect, I need to find the marginal cost. And the marginal cost is the variable cost differentiated. So the marginal cost will be 20 plus 2 times 1 is 2 over 2 over 1000. It's the same as 1 over 500x. You could write 2 over 1000. It doesn't matter what you do as long as it's right. So what I need is the marginal revenue, the marginal cost. So it's a C. Marginal revenue has to be equal to marginal cost to find this intersection, and that's very important. So what you do is that you say marginal revenue has to be equal to marginal cost. So you say 160. I hope you can see that down here. 160 minus 1 over 200. X has to be equal to 2000. You can use your cache tools to solve this one. Okay. What I found was that the intersection of this is at 20,000. X is equal to 20,000. So right here they intersect at a price of 20,000 units. What can I use that for? Well, I'm very interested in finding this point because right here where they intersect, the marginal revenue and the marginal cost is equal. But I can also find the marginal cost at 20,000. So what I do is that I put 20,000 into this equation, and I find this 20 plus 1 over 500 times, instead of x, I write 20,000. And that gives me a marginal revenue and marginal cost at 20,000, which is the optimal number of units that I'm going to sell at 60. So right here, the price is 60. So now I know my marginal cost of 20,000, which is the optimal numbers I'm going to sell, is 20,000. So it's 60. And I can use that. I have my price curve, which is red now, and red, so the marginal revenue is still the blue one. And then I go together down here and find the intersection from 60 right here and right there. So I have an intersection here and an intersection there. So the way that I will optimize the number of units sold on each market is by saying, well, this is the marginal revenue, the blue curve down here. But that blue curve has to be equal to the marginal cost. And the marginal cost is 60 because I'm going to sell 20,000. So I have the marginal revenue for the home market over here. And for the export market, which I start here, is 120 minus 1 over 100x has to be equal to 60. And that gives me 6,000. Okay. Yeah. And over here, I'll take the marginal revenue for the home market, which is 200 minus 1 over 100x, and it also have to be equal to 60. And I calculate that one, and that gives me something like, well, if I add the curves up, if I have calculated correctly, it will give us 14,000. 14,000. Is that right? Yes, it is, because 14 plus 6,000 is equal to the 20,000. So the only thing that I need to do now is to find the price, and that's the only thing that I'm going to do. So I'll put it in here and find the price. So 14,000 in that one, and the price will be equal to 200 minus 1 over 200 times 14,000, and that gives me a price of, on the home market, I did it before, 130 on the home market. So I erase that and just write the price on the home market is 130. And for the export market, the price will be 120 minus 1 over 200 times 6,000, and that gives me a price of 90. And then you can, times it and find the contribution margin, which you often, most of the times do. But as long as we find the price, it's the most important thing. I can always show you how to do the rest of the calculation, but I'll leave it with this. Okay, I hope that helped you to understand differentiation using horizontal addition of the marginal revenue. Bye-bye.